Hi folks, welcome.
Good morning everyone.
My name is Karthik.
And I'm Neependra. So we will talk about Noobernetes 101, where we're going to cover top 10 questions we get while teaching Kubernetes courses. I'm founder of CloudYuga, and we provide consulting and training around containers Kubernetes. I'm also a CNCF ambassador and CK. The course which Dan talked about on edX, which has more than 63,000 people enrolled, I authored that course for the Linux Foundation and the CNCF. So just a quick intro about myself. Just before I give it to Karthik, there are going to be quiz after this talk, and if you give the right answers, you get some prizes.
So Neependra just said that there's a quiz after this. It's not a test, but you can consider it as a test if you want to win cool stuff. My name is Karthik. I work at Oracle, and before everybody comes and asks me about DBA questions, we'll forewarn you that I know very little about databases. I know some stuff, but there's a lot more people that know about databases at Oracle. I actually work on the cloud side of things, so I work on a team called Cloud Native Labs, cloudnativeoracle.com. We have a ton of content there to help people get started with Kubernetes and the surrounding projects in the CNCF that have to do with cloud native stuff. I'm from Austin, Texas, and I organize a couple of conferences in Austin over there, and I've been in industry for a while. So enough about us. Quick question for the audience. Show of hands of people, like how many of y'all are developers? Most folks. How about operations? Okay, good. Everybody on the top seems like they're either DevOps or developers, which is good, because that's who this talk is for. And with respect to Kubernetes, how many folks are new to Kubernetes? Show of hands, a few new folks. And do you guys, do you have experience with Docker and containers in general? Show of hands as well. Good. And then would you classify yourself as like a noob cube? So first time Kubernetes, I don't know much. Okay, good number of people. So that's great, because honestly, it's a big platform, so there's a lot of stuff to kind of cover. So today's talk, we're going to basically talk about all of the most common questions that Neependra and I have gotten over time. So I actually authored the LinkedIn and lynda.com courses for learning Kubernetes and a bunch of other CNCF stuff. So we have some interesting things to talk through. The whole point of this talk is for you to leave with more answers than questions. And if you still have questions after this, come talk to us. We'll be out here.
Thank you. Okay, the first question is, why do we need containers when we already have VMs? When people start talking about containers, we generally say that containers are lightweight VMs. It is good for analogy, but it is not true at all. What you get with VMs is you have a hypervisor in between. In hypervisor, you would deploy a guest OS, and then you put your application on top of that. But remember, the end goal is to run the application, not to run the VMs. So as I can run the applications on my environment and I can save cost, that's going to be a benefit for myself and my company, right? So in the container world, you kind of run everything on one host OS, which means you're sharing your host OS there with all the containers, which gives you more density. So you can kind of save cost there. You can have more density of the containers and the applications there. Once you made a containerized application, you can deploy it anywhere on an environment, be it on a workstation or on the cloud. It works as it is. And it becomes very easier to manage because you have containerized it. You might have a manifest file for Kubernetes or Docker, and you just run one command and the application gets deployed, same everywhere. So let's talk about another kind of thing. What we are seeing right now is lightweight VMs, where you could now have a VM, one VM per container. So this lightweight concept is coming right now, like Hyper-V containers, Kata containers, AWS Firecracker, where you deploy one VM and one container together. That way you get security of the VM, but the benefits of containers. So once you kind of talked about containers, then we kind of move to Kubernetes. Then people ask questions that should we deploy the Kubernetes on-prem or on cloud? Of course, there is both pros and cons for both of them. With on-premise, you need to kind of manage everything on your own. It would be a bit hard to expose the application to the external world, but you can definitely do it. Similarly, for the storage, there are softwares using which you can scale the software even if you're on-prem. But of course, on the cloud, you don't have to care about the control plane of the orchestrator there. The cloud provider would manage for you. Then there are things like LoadBalancer, Ingress, auto-scaling that would all be managed by the cloud provider for you. So it would be good to go start with maybe on cloud, and then as you kind of become comfortable, you can maybe come down to on-prem if you have a really requirement there.
So the next part that we kind of come to is, self-install Kubernetes and manage Kubernetes. Neependra touched a little bit on this, but let's take a look at this in a little bit more detail. When Kubernetes first kind of came about, you had to actually spend a lot of time to install Kubernetes, get it up and running, etc. So, the canonical examples of this are, if you're using AWS, you might use kops for AWS, or you might use a Terraform installer to install Kubernetes on wherever you're kind of running it. In this case, you as an ops person or developer are 100% responsible for the cluster. So if the cluster goes down, that's something that you are kind of taking care of. And like some of the typical use cases for this are, when folks are installing this on-premise, typically you'll have a team that installs your cluster, does the operation stuff for the cluster and make sure everything's up and running. And the other use cases, if you have something very specific that you're trying to do, you have like custom cluster requirements. That's where we see a lot of folks using the self-install Kubernetes version. So I grew up in the 80s, and I give this analogy of you are like He-Man or you are like She-Ra, and you have all the power to do whatever you want with the cluster, whether it's, if you want to change things, you have the ability to do that. So with the managed side, if we take a look at that, I have this little diagram here that says, customer managed, which is what we did initially. On the managed cluster side, you are kind of responsible for the applications. So Neependra mentioned a little while earlier where, we have this idea of a control plane, and the cloud provider kind of manages the control plane, which kind of helps you with the scaling, high availability, backup recovery, and all of those kind of things. So you're kind of offloading some of that work to your cloud provider, whoever that is. The benefits of this is, you don't have to spend a lot of time creating your cluster. You can just, click a button, or maybe run a script or something like that to get your cluster up and running. It's lower risk because you don't have to tweak a lot of stuff up front, and it adds business value because you're trying to innovate a lot faster. So my analogy for this is, it's like VOLTRON. How many people, well, maybe this shows my age, because I grew up in the 80s, but I kind of see this as VOLTRON, where it's like, everybody plays their little part, but then when you're trying to do everything together, you form VOLTRON. So it's all about teamwork between different teams in your organization and your cloud provider to get your platforms up and running. So one question that we get a lot is okay, there's many ways to do this, to solve the same problem. Help me choose one way or another. So if you're looking at the managed managed Kubernetes service providers, some of the pros are, you're offloading a lot of the work to the cloud provider. So you don't have to worry about some of that. And you're spending more time developing, debugging, deploying your applications, and less time on the infrastructure. So from a developer perspective, you're trying to make your microservices work. And then also from an ops perspective, you're not worried about the control plane, so there's less operational headache that you kind of have to worry about. The consequence of picking a managed provider is sometimes you don't get a lot of customizability. From an Oracle standpoint, for example, we might say, hey, we've made some decisions for you. And every cloud provider kind of does that. In specific use cases like regulatory or specific networking, etc. And there might also be hidden costs associated with that. So a couple of things to watch out for. And so I kind of wrote this recipe where if you're new to Kubernetes and if you're using cloud, start off using a managed Kubernetes provider, whether it's like on Amazon or if it's on Azure, Oracle Cloud, whatever. Like everybody has a managed service. So start there, kind of get understanding of like how to deploy your applications, develop your applications, and kind of play around in the Kubernetes ecosystem. You'll start to find like, okay, for specific applications, you might have specific requirements. So you understand your gotchas, and then if you actually realize, okay, well, I really need one specific kind of networking, then you can kind of shift back to doing it yourself. But the other on the flip side is if you're kind of doing a lot of things on premise, then you probably want to start with a self-managed to begin with. To kind of move on, so whenever I ask people like what do they mean by cloud native, and everybody kind of has like a different definition of this over time. So some people say like, oh yeah, you deploy like microservices with Kubernetes continuously using a CI/CD pipeline, and almost every word here except the words using an is a buzzword. So it's a little confusing. So the question that we get is, do I need to break up all these things, do all these things at the same time, or can I kind of break this up? And my response is, well, it's like blind man and the elephant, right? Depending on what kind of part you're touching in the elephant, it's like, oh yeah, it's like somebody might say, oh, this is cloud native. Somebody might say, no, this is just like CI/CD. Somebody might say, oh, this is just a container. So like, how do you kind of take the next step? So basic principle here is that Kubernetes is a platform. And Kubernetes plays really nicely with a lot of different things. So you can kind of orchestrate it to do a lot of different things. Your job as a developer, operations, or platform engineer, whatever, is to decide on the priority of what you want to do. So if you want to like kind of think about a strategy here from a high-level perspective, so have a plan. So Kubernetes, you probably want to deploy your applications as microservices. So have a plan for microservices, and one way that everybody kind of collaborates is with the YAML. So collaborate around the YAML stuff to define like a specific language for your whole team, whether it's like development, operations, whatever. You can kind of collaborate on that specific thing. Think about having a CI to build your container images, because a lot of the stuff is based on containers. If you have a pipeline to build your images with containers, like do that. Also use the same CI pipeline to be able to push those images to a registry. And then, once you're kind of done with that, have a deployment strategy set up for Kubernetes. So I'll turn it back to Neependra.
So there are different ways where you can use to deploy the applications on Kubernetes cluster. One is simple. You can just have your YAML or JSON file. You can put them in your source code, along the source code, and then deploy it. And there are tools like Draft and Scaffold. They can kind of watch the changes in your source code and deploy the applications for you so that your dev cycle becomes very easy. So that's where Draft and Scaffold can hold a kind of benefit you, where you have a source code and then just point those tools to that source code repository, and it will deploy the application for your development and debugging. Then there are tools like Helm, KSonnet, Customize, which can kind of convert eventually to a YAML file, but they would help you to do it in a way where you parameterize your parameters. For example, you can say, I want to parameterize my image name, my replica count, and so on. So you can parameterize them, and then those tools would eventually deploy the applications for you. Then there's the concept of GitOps. You might be hearing more. So with GitOps, it's like kubectl plus Git. So nobody does nobody runs the kubectl command on the production. What you do is you kind of have a Git repository where your ops team do like a check-in of the code, which is the command. For example, if I want to change the replica count of the image of my application, I would go and make a check-in to my source code, and there would be tools which supports GitOps like Ardo CD, Jenkins X. They're going to watch those GitOps, Git changes and deploy the applications for you in production. So with GitOps, you kind of get the history of who made what changes in my deployment or in my production and so on. So it's a really good thing to do. So once you have deployed the applications in your cluster, you would want to expose them to the external world. And there are different ways which you can use to expose those applications which you have deployed. So here's a quick intro about Kubernetes architecture here. So we have the Navy server, which kind of does all the control stuff there with other components. And then we have kubeproxy. That kubeproxy runs on each node in the master as well. The kubeproxy allows the external access of the application. So when you hit any URL which is getting served by the Kubernetes cluster, you are eventually going to hit the kubeproxy on any of the node, and which would kind of take you to the inside cluster and expose the applications. So one of the way is a cluster IP. The cluster IP does not expose to external world. It is internal only IP which you get when you deploy your services. For example, database applications would be like that because you don't want to expose database to the external world. Database would be of type cluster IP. And there's a DNS server which runs with the Kubernetes internally, which kind of going to do the mapping of your name to the IP and so on. Then what we can do next one is we can expose services with the type NodePort, though I think it's not visible there, but very clearly. But what you see there, the blue one on the top of each node is called NodePort. So we are exposing our services by the type NodePort. So that NodePort is like you're blocking a port on each node. And whenever you hit the node port on any of the node, the request goes to the service, and from service to the pods. So if you look at here, we don't have any pod running for the blue application on the node 3. But as we hit the node 3, our traffic routes from the node port to the service and then to the pods. But you can't use the node port to expose your public services. I mean, you can use it, but you will not prefer it, because if you give a customer an IP and the port number combination, it's going to fail. I mean, customer would say, why are you giving me this thing? You give me a DNS name, something like that. So NodePort cannot do that for you, because the DNS, there's a limitation in the DNS, the way it has been built. DNS cannot take the combination of IP and the port. It can just take the combination of name, and it can map to a complete IP address there. So for that purpose, we have a service type called LoadBalancer, where we expose services with LoadBalancer, and underlying cloud provider would help you to create a LoadBalancer IP or the DNS name there. And as you get the LoadBalancer name, you go to the one of the node, and from the node you'll go to the service and the pods behind the scene. Then there is something called as Ingress. So with the Ingress, you have, so I mean, if you have, for example, if I have 10 applications with the type load balancer, I'm going to create 10 load balancers, which is not going to be very scalable for me and as well as expensive. So what I'll do next is I'm going to deploy something called as Ingress controller, and I'll deploy the Ingress controller as one type load balancer. So instead of having 10 load balancers of 10 services, I would have just one load balancer for my Ingress. And that Ingress would then map my names to the services behind the scenes. So for example, you can see here two examples. One is fan out. So where we see example.com/blue or the green, from where I'll go to the blue or the green service. Other one, I have the virtual hosting example where I say blue.example.com or the other, whatever the color is there. With that, you can kind of come to the right service there.
So it looks like you're saying that you can use a single load balancer and then have like multiple things behind the scenes. True. Using the just
yeah. So you kind of save cost, and as well as you can better scale there. Yes, so it's the same thing what we talked about. This is like Ingress, how do you deploy it? So you have an Ingress controller pod, which kind of takes care of the backend stuff. So I'm going to just leave it here. You can look at the slides later for kind of getting more details there. So there are other ways also by which you can access the applications like ALB from Amazon, then we have Google Load Balancer and so on. They can also help you to kind of allow the exposing of the application from the cluster to the external world. Yeah.
So to kind of move on, we talked about Kubernetes itself, but one of the interesting subsegments is, it's not just Kubernetes today. There's also concepts of serverless and concepts of service mesh. So let's take a look at this a little bit more. One of the questions we get is like, should I be using Kubernetes or should I be using serverless, or should I be using Istio instead of Kubernetes instead? So some general knowledge on this is speaking of Kubernetes, the general answer is, everybody in software, if you've been around for a while, they say, well, it depends on your use case. And so we're always kind of, keep saying that. But the real answer is, take a look at the problem that you're trying to solve, and then see if Kubernetes actually solves that problem for your team or for your organization. And so, and the other thing that kind of happens is Kubernetes is actually a platform. So there's a, you need kind of a team to be able to manage that platform. Either if you're doing it on managed Kubernetes yourself, etc. So ask yourself a question: if you're like just one developer, and if you're in a startup or something like that, and you don't have like a large team, like, are you ready to manage a brand new platform? Because there's some work associated with that, and also consider kind of your use case behind it. With respect to service mesh, so in my opinion, everybody has an opinion, but my opinion is that service mesh is kind of like a subset of Kubernetes. So, and it works great in a bunch of use cases, but before you start using Istio and before you start using like a bunch of other stuff, like get some experience like running Kubernetes in general, because you will have issues. A lot of these things run on top of Kubernetes, so if you don't know how to like manage Kubernetes in a production setting, you might be setting yourself up for failure. It's also new and evolving, which is great because there's a lot of new things coming up into the ecosystem from that perspective. So my advice would be, don't over-engineer, because chances are, right now some features you might want might not be there, but they'll probably be coming because somebody will end up writing a pull request for that. So don't over-engineer. With respect to serverless, in my opinion, serverless fits really well with development teams. So if you have like no operations experience, really great fit for the smaller kind of teams. Great number of use cases. And so I've started to say, think about like, why can't you use serverless for a specific scenario, whether it's Knative or like something like very specific like FN or functions, etc. And if you don't already use Kubernetes today, like ask yourself that question, like, can you use serverless for this specific scenario, and kind of go from there. Okay. So next up, so we talked about, Liz had a great talk on all the different things that we do between RBAC and authorization, etc. So questions that come up is like, how do you add users to Kubernetes? How do they authenticate? And like, how do you kind of scale Kubernetes for teams? I won't spend too much time on here on authentication, other than there's a bunch of different ways that you can authenticate. The most important kind of takeaway is make sure you read the docs so you have a way to authenticate. And whatever you do, don't not do anything. It's like double negative, but I don't know if a better way to say it. Because if you don't have an authentication strategy, you cannot do anything with respect to authorization. And that's a bad thing, because you really, a lot of applications today depend on Kubernetes authorization. So you want to have like an authorization strategy. One tip on the authorization part is everybody today in the community, for the most part, uses RBAC for authorization. So that's kind of become the de facto standard. ABAC was like the initial thing, but it's kind of going away, and not a lot of people use that. For authorization, there's like a good set of defaults. You can take a look at the slides later for different RBAC policies that you can kind of define. And if you're using authorization with like multiple authorizers, it can get confusing, but you can use them together. The idea is the first one that wins, the first authorizer that passes your request ends up winning. And in terms of like teams, right? So there's a concept of, okay, I have a large team and we're all using Kubernetes. What are some best practices and what are some ways we can use this? There's two answers to this. One is namespace, and the other is separate clusters. And so with namespaces, it's easy to use namespaces because you're still running in a single cluster. And then namespace helps you kind of separate out your work for your team versus another team, etc. If you decide to use separate clusters for, let's say, your dev and integration, production, or even separate your clusters by teams, it kind of helps you with separation of concerns. So like if you're trying to do like the finance team can have their own cluster versus the e-commerce team can end up having their own clusters. And a lot more people are treating this as cattle and not pets. So especially we see this a lot on the managed side, where people will just kind of shoot a cluster and they'll be like, it might be their production cluster, but they'll end up deploying a brand new cluster, deploying all their stuff to that new cluster and killing the old cluster instead of updating and managing the and all the cluster. Oh, this is still mine. Okay, so what are the best ways to handle secrets, search credentials? Oh yeah, I forgot. Sorry. If there's there's actually 10 important things we covered, but this is probably my most important thing in this talk. Is there's credentials and secrets and how to manage these things. And I feel like more people get this wrong than right. If you're new to Kubernetes, please take a look at Kubernetes secrets. Because Kubernetes secrets is the way to store all your sensitive data. So if you have database passwords, if you have something very sensitive, you want to use a Kubernetes secret. Once you're kind of already following that best practice, you can take a look at their secrets encryption providers. Secrets are actually stored inside of Kubernetes they're encoded with base 64. So it's not really encrypted, it's more encoded. But you can actually encrypt it using an encryption provider. So those are a couple of ways to handle that. But for what it's worth, make sure you're actually using Kubernetes secrets.
So we talked about deploying the application, exposing it, and then putting it as secrets there. I will talk about the last point there, how do we store data in Kubernetes? Because eventually you want to put some data in your application or manage the data from there, right? So we have a concept of pod in Kubernetes, and a pod can have multiple containers. We assign a volume to a pod, and then each container in the pod can decide where they would like to mount that specific volume to. So for example, container 1 can say I'll mount on /mnt, other one can say I'll mount on /tmp, whatever. So, but they can choose to have a different mount point there. Then there are different drivers which you can use for expose or kind of mounting the volume, like empty, like a scratch pad. So empty is like a scratch pad which kind of goes as your pod dies. So actually no real world use case, but it's good for doing the testing there. And we have host path where you can share the host directly to the container of the pod there, and NFS and other cloud providers volumes like EBS and so on, which you can assign to your pods and then mount it. But to decouple it, what we use is something called as persistent volume claim. So what we need is a way where developer can say, I want a volume of X size. Now, the developer don't have to care about whether it's coming from AWS, Azure, or whatever it is. So the developer says, I want a volume of a specific size. And for that, the developer creates something called as persistent volume claim definition, or PVC. So there, he would say, I want a size of 5 GB maybe. And somehow it should come. And it can come from two ways. One is from the static volume provisioning, in which the cluster manager or the admin would create the volume manually for you, and then which the developer is going to consume. That's one way. And the other way is dynamic volume provisioning, where you have a concept of storage class. And with the storage class concept, the developer says, I want a size of 5 GB. Dynamically, that volume comes from backend. For example, here I would say the storage class is AWS there, right, or whatever. So developer says I want a storage of 5 GB, it goes to the storage class, and behind the scene it can come from any of the driver what has been configured by the cluster manager there. So with that we can kind of manage both volumes with the dynamic and the static volume provisioning. Mostly people use dynamic volume provisioning because you want to kind of don't want to kind of assign the volume ahead of time. You want when you need it. And there are some drivers which can also, suppose you created the volume of 10 GB in the beginning, now you want to scale to 10 to 15 GB. Then there are some drivers which can help you to scale from 10 to 15 as well at runtime. So that's our last question what we had for what we kind of plan to discuss today. So where do we go from here? First of all, as we kind of know that there is a free course available on edX, which kind of covers all of the basic questions we asked, and you can take that course for free. And then, of course, as a company, CloudYuga, we provide trainings and consulting, so you can, of course, check out our sites there. And as we mentioned about, there's going to be a quiz. So here is the slide for the quiz, and so the questions of this particular quiz would be the we talked about right now. So you can take the quiz and then win. We can. Slide.
Do we miss a slide of like?
Yeah, we missed the slide from Karthik.
Well, I was just going to say on that. So the other, like my recommendations would be, take a look at the edX course that Neependra talked about. Take a look at cloudnative.oracle.com. That's where we're actually pushing out a bunch of things that our customers are kind of asking us for. How do I do Kubernetes and whatnot? And yeah, I think that's about it.
Yep, that's it. Thank you.
All right. Thank you all.
Thank you.